Okay, welcome back everyone. Tonight we are starting a new Dan Does Data series, or maybe just something we do from time to time. We're going to be building an autonomous car model. And what I mean by that is we want to be able to train a car how it should react on the road, or in a closed course setting, say, given some inputs and some allowable outputs. This is sort of different from, this is like some autonomous car models and unlike others. This is part of the Power Wheels Racing series. If you go to powerracingseries.org, of which Fubar Labs, a local hackerspace near me that I'm a member of, competes in. This is a competition where people take a little tiny electric car for children, this Power Wheels vehicle, and no more than $500, and they soup it up and they race on these small little courses. And so here's the Fubar team, or part of the Fubar team on the left here. I don't know how recent this competition is. But there's an autonomous competition this year. And so we're going to try to do that. And I'm focusing on the model aspects, and I probably won't be driving the car. That would, well, certainly I won't be driving the car if it's autonomous. I don't think I'll be sitting in the car. I am not the lightest person on our team. Neither am I the heaviest, but sort of that's going to be the goal. If you want to learn more about power racing, again, go to powerracingseries.org. You know about Fubar Labs' hackerspace, go to fubarlabs.org. But regards to, in regards to building this autonomous vehicle, I had previously done some computations for a fleet of autonomous vehicles and how they should follow each other. And I had done my background is civil engineering, so this is something, studying traffic is something I've done before. And I worked out some numbers, and I built a simulator for it, and I was going to show it to you guys, but it's all written in the C++ and this SFML, Simple Fast Media Library. But I tried to recompile it today, and naturally, things didn't work. So I don't know what the problem is. Does GitHub render LaTeX? It does not. That would have been so cool if it did. Yes, it's so if you have gotten SFML 2.0 working on Arch Linux, do let me know. I would love to hear about that. I've had it working as recently as like a year ago. I haven't touched that project in a while. If we go into it real quick here, you will see the problem. Cat my makefile, doing normal things, linking my SFML. When I go to make, it says you don't have SFML, but only for certain things like this font and string. So I don't know if like they changed it since I used SFML. This was a couple years ago, or what. I might come back to this just because it is like it's a nice little simulator where you can drive the front car, and all the cars behind you try to follow at the closest possible safe stopping distance. And that distance depends on your speed, your braking ability, their braking ability, your reaction time, their reaction time, and all this cool stuff. That's not directly relevant to what we got going, what we're going to be working on today. Today, I just want to set up a model to start thinking about this. I don't have any data yet, is the problem. So I just want to work out and define what kinds of inputs and outputs do we want our model to have. And remember, everything's got to be cheap. I believe we're going to have a computer with a GPU to be able to compute the model, or like run the model while it's on the car. So that's not going to be too big of a problem. But let me just sort of sketch out, literally, in GIMP, what kind of situation we're in. So imagine that you've got a camera, and so you've got some image of the view ahead of you when you're in the car. At every frame. Maybe you got 10 frames a second, maybe you got 30 frames a second, whatever. You've got some image input, and that's sort of like the simplest thing you can possibly have from a webcam, say. That's not the simplest thing, but that's something simple you can do. You could also maybe have like a rangefinder on the front of your car, or maybe the sides of your car. You could have some real value, some distance. Like if you had LiDAR, it would be a really fancy version of this. But you could have a simple rangefinder that just says, from going out linearly from this point, I believe you have this much distance until you hit something. This can be helpful, for example, if you are the owner of a Tesla vehicle, which doesn't have a rangefinder, I believe, for its automatic. It uses only LiDAR. And so it got confused recently. A truck crossed traffic in front of a Tesla vehicle. The Tesla vehicle, very naturally, because it was very, very bright out, could not distinguish the white truck from like the very sunny white background, and so it kept going. Honestly, a human being probably would have been killed too. Just you have to be wary of these kinds of things. So an additional input, such as from a rangefinder, might help you with that, because it will respond to a physical object, not just the visual input. Figure we might as well get that information. So this is the kind of inputs that you have. Some kind of image, maybe some kind of real value here. And you have this in time too. I should maybe move this little... move this over there. Okay. Maybe you've got this in time as well. It's like none, all, good. Background. Clearly I don't know how to use GIMP properly. God damn it. Undo, undo. Yeah, clearly I don't know how to use GIMP, because I'm screwing this shit up. Alright, screw it, screw it, screw it, screw it. There we go. You know what? I'm just going to redraw it. Pretend that's the easiest thing to do, which is scary. That redrawing is the easiest thing to do. And you've got some... Jesus. You've got some real number D here. And this is all in time. So you've got some of these. God, this needs to be a little bigger. There we go. You've got some image and some range at every time. And so you can remember history going back in time. And the question is, what do you want your car to do? And I think I envision there being like three things your car can do. You've got, first of all, the gas, the acceleration that you want. So that's a certain number out you want. You've got the brake. That's another number out you want. And those, you might argue, are actually the same value. Hang on. That the brake is just strictly less than the acceleration when that's 0. So you can fight. Maybe that's what you want to do. Sometimes it makes sense to do a little bit of both. We'll see. And finally, you need to know what angle you want your wheel at, your steering wheel. So how much do you want to turn? And so you've sort of got 0 degrees here. Oop. And I don't know, maybe you can turn it 90 degrees or something. That's something you can scale. But suppose you can turn it 90 to -90. And so you've got a model where you want multiple outputs, and you want this at a given time. I guess you also know, in theory, what your previous time step, what your input was. Yeah, and you really ought to know your current speed. All right, there's more inputs than I alluded to. You want to know like your current speed, your current acceleration. You don't know if you're going forward or turning or not, I guess. I guess that's what this is. And you want to know what your current angle is. Hang on. So this is why I'm talking this out, because this is sort of the first I've sat down to think about this formally. This might take up the whole hour, might not, we'll see. And we'll say our angle phi I minus 1. There we go. S of I minus 1 and acceleration of I minus 1. you may or may not have this acceleration information, I guess, depending on the things you get to have in your car. Like an accelerometer, that's a pretty common component. That's easy to include. Speed, maybe you can read from the wheels, I guess. That might be the way to do it. And then phi you should be able to get to know. The angle of your steering wheel. Okay, but the question is, how do you go from all this stuff up here to all this stuff down here? And if you're using, say, like a machine learning approach, I just want to have a whole bunch of these values. So really in time, I'm going to have a whole bunch of video of a video from the webcam strapped to the front of the vehicle of someone doing someone like literally going around a track. Then I'm going to have also like the rangefinder logged input, and hopefully all this other stuff logged. Their acceleration during all the time, their speed during all the time, their what angle their steering wheel was at during the whole time. Maybe I have this from a real like training run that someone did, and we strapped all this equipment to the car. Maybe I'm lazy and just like I'll use a video game, and I'll just use that as my information. Like you could get Mario Kart, frankly. That might not be the craziest thing. You would want something that's very photorealistic, or an environment that resembles the Power Wheels Racing. And just so you're aware, the Power Wheels Racing happens on this like hay bale lined track with pavement usually. And I think for the autonomous race, they're planning to have like one side striped red and the other side and like the inside striped green, or maybe the opposite of that. So they're trying to give you some like easy things to key on, but I don't want to key off of that directly. That's going to be dangerous because people wear all kinds of crazy colors. I don't know what's going to be out there. I don't know if that's true. So you could imagine using a video game, and you could have like the actual video from the video game. I don't know how you would get the range. You'd have to have some way to extract this information. So maybe some like open source video game might be better. And the other question is, how big is the frames of your video? I honestly don't think this has to be super high fidelity video for like, and I won't be able to build a model until I know for sure, but you know, I would try something small, maybe 64 by 64. I mean, very simple. And you could try it with 3 color channels. I would try it with just black and white at first, but okay. And actually, okay, and if you're doing some kind of machine learning thing, then you could envision, okay, I'm going to have a model to take all these things to compute my acceleration. I'm going to have a model to take all these things to compute my braking. I have a model to compute all these things to compute my wheel output. Or you have one model, whatever that model is, and that model has 3 outputs, or however many outputs in this case, and however many inputs. And this is something you can do. You do need to be careful. Like your loss function is going to get really complicated, because I almost put my hand up like over the screen as though that would block the image. Here, let me. There we go. You can, in a traditional model where you've got like one output, like the loss function is very well designed. Here, like this is a regression problem. What's the acceleration be? How much did I hit the gas pedal? Okay, that's a certain number that I can have. Probably I'm going to bound it between like 0 and 1 and then just scale that to however much I can actually do. But once I say, oh, well, I want to output the loss of that and the loss of this. Well, now you need to be careful. So like, do I just sum up the loss and the sum of this? What if these things are correlated? And we talked about these might just really be one number. You're never going to gas and brake at the same time, maybe. Maybe you would. I vaguely recall some like old Speed Racer cartoons where he definitely gasses and brakes at the same time. But maybe that's not a good model to go from. And similarly, you're going to have a restricted value in your steering wheel. And so you could just, in fact, scale that -1 to 1 is that's how I would do it. And you could consider just going 0 to 1. But that brings along its own issues. Because when you do a typical machine learning problem, you're doing regression, you are saying that my output value can be negative to positive infinity. But when you're doing a model like I just described, I'm like truncating or clamping my results. I'm saying I can only do this. And there's a question of, well, what's the right way to handle that? And you could say, well, if the model predicts less than this actual value, I truncate it to -1 or whatever it's going to be. I mean, you can do that. That's it's not 100% statistically valid way to approach the problem. Because your inputs that you're putting into this model, the steering wheel inputs, those aren't negative to positive infinity. Those are like negative 90 to 90 or whatever. So your inputs are not like uniformly, or the error terms are going to be really screwed up. So you're going to need to be careful. I don't know how rigorously I'm going to worry about this, but it's something I want to be mindful of. That I have multiple outputs, so if I'm summing their loss functions and there's correlations between these things, we could be in trouble. For example, if I'm turning, my acceleration is likely to be lower. I might even be braking while I'm turning. Even something simple like that. Can throw off the errors, can throw off your statistical assumptions, and everything goes out the window. And your model is, it may appear to give you good error results, but in fact it might be bonkers. Okay, so that's kind of the idea. It's like you've got, if you want, you can think about this as like an autoencoder partially, because these are sort of the things that we'd like to output on the end. We're going to input these for training. I sort of like to get the same things back out. Right. But it doesn't really matter. That's right, that reminds me. I need to submit to Reddit. Thank you, guy in chat, for reminding me about Reddit. I appreciate that. Okay. And yeah, so you sort of have this auto-encoding aspect to it, but you have extra information over here. But I'd really not like to think about it like that, because you're not trying to auto-encode the visual stuff. You just want the car inputs, outputs. So the question is, how do we translate this silly picture into a proper machine learning model, maybe a neural network? I have a feeling that's the way it's going to end up, because we've got image input here that we're going to want to run some like convolutional neural net on, plus this other stuff that we're going to want inputs, which brings me to, we kind of want to do another Keras graph model, just like we did last week to handle the convolutional RNN model. I think we did a graph model. Did I lie? Hang on. I have a hard time keeping these things straight. Yes, we did, because we had 8 inputs. In fact, it's going to be shockingly similar, because we're going to have 8 inputs plus this convolution stuff, and then we'll be doing some other stuff. We'll do some convolution on those. Well, let me draw another picture of what I think this is going to be. So keep this in mind. This is our inputs and such. We'll put that down there. Put this over here. Move this out of the way. Okay. I want my acceleration in, my speed in. I want the phi in. I'm going to want the rangefinder distance in. And I've got some convolutional stuff that I'm going to want in as well, too. The actual image. And maybe I have these things in time going back a ways. Maybe I don't. So first, this is going to go into some kind of convolutional model, right? I want to sort of identify what is going on in this image that my webcam strapped to the front of the go-kart can see. it doesn't have to identify exactly, it just has to extract out the important features. For example, where the heck the sides are, and what are other vehicles that are in the way. So we're going to do something like that. And the question is, yeah, we're going to end up having to flatten this out at some point. And this goes into some flat network, say, or dense. That goes in with our acceleration, our speed, our input, angle of the steering wheel, and whatever our distance is. And maybe you've got multiple layers here, times n. Maybe you've got a bunch of layers here, times m. Whatever, who cares? And then I think the sensible thing to do is you're going to have some final layer, or maybe some small series of final layers. So I'll say these things go over here, these things go over here. Whatever neurons these are, those compute my acceleration, say. How much I want to hit the gas pedal or the brake. And these neurons over here, a couple other layers, these compute whatever this is, whatever my angle of the steering wheel is. I don't know why I decided that is the symbol for like the angle of the steering wheel, but that's what it is now. So you can sort of think of at this point, let me change colors real quick. You've sort of condensed all of this information into something very useful. And like this is what you're really building a model of for what your acceleration should be and what your steering wheel, your angle should be. But that's all. Okay. That's sort of the plan of attack. What do we have so far? Zip. Nada. Nothing. I've got some import statements. I have no data yet. Getting data for this is going to be a pain in the neck, I imagine. I'll probably do that off screen. But so right now, we have nothing. Because that's what this channel is about. Starting from scratch very often. Let me see. Let me take a quick drink. Oh man, chat is hilarious today. That's funny. Okay. So what we want to do is steal some of our code over here. And let's just straight up steal it first. Let's do this. Right? We're going to have several inputs that we're going to want. And those are all going to sort of need to be different. Ooh, yeah, there we go. So we have a cell in equals input. The shape equals 1, I think. I think there's just 1. It's just it's a straight up scalar input. Oh, these are all sort of scalar inputs. So those can go, these things can go together into one for-long input. That would make sense. Let's say real in. A scale in? Yeah, real in. I like real numbers. That sounds good. Name equals real input. That's fine. Yes. And then we got video in. Or we'll call it frame in. For the moment, I will not worry about the time aspect to this. And we're going to have one channel, and just for the sake of argument, we'll say nrows and cols. And I will declare frame size nrows equals, I just want to say 16 to have something now, and cols equals 16. There we go. And yes, there we go. Ugh. Okay. So those are going to be our inputs. These are for I'm going to make a comment for myself so I don't forget. It's going to be acceleration, speed, angle, distance. Let's go acceleration, speed, distance, angle. Although those are, like, those sound like very typical physics things that you would do. It's the past acceleration, the past speed, distance to the nearest object in front of us, and whatever the angle of the steering wheel is. And this is a video frame in grayscale. Okay, and then we're gonna, first thing we're gonna do is set up some kind of simple convolution for the frame input. So there is one channel in this case. 3x3 sounds fine for the moment, just for giggles. Yeah, I think 3x3 is good, especially if I'm planning to condense this down quite a bit. I'm not setting up a whole bunch of convs, so I'm going to change this to conv layer, pool layer. This is going to be conv of frame in, right? Yeah. Perfect. And this is just max pooling, pool size 2x2 of conv L. There we go. This is, eerily enough, starting to make more sense to me. The question will be how we handle the outputs. That will, I strongly suspect, be an issue for me. Okay. I need to flatten some of this data out, but I just need to flatten pool L is all. Call that flat. Like, not conv out. Let's call it flat. Flat's fine. Nothing wrong with that. And then I want to merge. What am I merging? Grab this. I'm stealing all my stuff from my font classification model. I want to merge flat and real in, I think. Ooh, need a comma. Real in. There we go. Concat axis. Oh shoot, how does that work? Also, I should get rid of this stuff. Don't need that anymore. Okay. Integer axis to use in mode concat. That shouldn't matter since I only have one axis to work with. So what was I doing here that I was concatenating? Yeah, I'm not worried about it. I'm not worried about it right now. Probably later. Yes, I will inevitably screw things up. Here I did silly things. Then you could have dense. Let's just suppose for... And I need a model thing, don't I? No, I don't. The model is made from this. Cool. Oh, and you're going to multiple outputs. Excellent, excellent. Oh. So let's have dense 1. Activation sigmoid. That doesn't sound right. Keras. Show me the guide. I feel like I so rarely build a regression model with something like Keras. Usually I'm doing regression, I'm being super serious statistical about it, I'm using R. I just really want an example. That would be ideal. Guide the sequential model, multi-input, multi-output models, sure. Let's take a look at that. Main output dense, this is probably going to be a classification problem, isn't it? Oh no. Main logistic regression layer. Well, that's going to be binary cross entropy, I bet. More examples, there we go. Inception module. Let's try the sequential module. I have a feeling that's going to be... geez, seriously? Examples, here we go. I don't want to do classification, I just want to make sure... Congenet, classification... All this classification stuff. No regression? Really? I know Keras does regression. It's just I would have thought they would have included an example that did that, because that's such a core thing to do. Alright, well that's weird. In that case, objectives. That's going to be mean squared error is what we're going to typically do. We might get burned on this, and I might get super burned. So like the loss is mean squared error. The question is, how the heck does that happen when I have multiple outputs, as I am going to have? All right, we'll say d of 1. And this will be in fact a. And this is not, this is reading off of n. There we go. So we're basically building a linear model of all these things. Just because that's the simplest thing to do first. And also, I want I'm going to call it phi. That's how I like to think of it. Yes, we have that. I think that's right. So that's the angle, that's the acceleration. And for the moment, I'm not going to worry about braking. I don't think activation sigmoid is really what I want, though. Activation linear? Yeah, I think that's what I want. Or like even activation identity. I think activation linear is what I want here. I'm pretty sure linear is an activation layer. You say advanced activation layers. Core layer? Is that because there's core layers here? Maybe that's the case. Someone's asking if you managed to set up Slimux properly. And I'm very sad to see that you gave up. That is unfortunate. I started with Vim Slime, so I'm not surprised that you got that working. At some point, I'll have to walk through how to set up Slimux one of these days. You might check one of my early videos. That was like one of my first YouTube videos that I did not advertise in the slightest. But I don't know if I walked through how to set it up, but I walked through how to use it. But that is a good point. That is something I should definitely do. Right, I wanted to know linear. Is activation a thing? What are my possible activations? Name of activation function, C activations, activations.md. You know, I would activation. Alright, I just didn't see it. C activations. Available activations. Linear, okay, yes. So I happen to want a linear here because I want just one thing out. And I want this to start as a linear model. But we'll get there when we get there, sort of. Alright, so then we specify our model with our multiple inputs and outputs. Our inputs, I think I just give it a list of stuff, right? Properties. Really? Really? To do, docstring. Alright, that's fair. That's fair, pal. Let's see what we got a little more. Take a look inside. Inputs, input. Self.inputs. Wow, that is way down there. Inputs equals self.inputs, self.targets. I bet I can do a list. It is not clear from that, though. Let's just do that. So input equals real in, comma, frame in. Output equals a, comma, p. And in this case, I want mean squared error, because these are regression problems. Make sure that's the exact how they spell what it means. Square error means squared error. Easy to get burned by this stuff. Mean squared error. Okay. That's fine. In this case, these are two regression problems because of how I have framed them. So I don't think I'm going to get burned too much. But I'm not sure. I would have to write a custom loss function if one of these is a regression problem and the other one were a classification problem. And this might come up if I decide that, you know what, I don't even have explicit control from -1 to 1. I really need to just be dividing this up into 10 slots or 5 slots or whatever. And I say, all right, those are the only ways I can turn at very fixed, discrete points. And so now that's a classification problem. Although in this case, doing your standard categorical cross entropy is you're gonna get burned because you care how far off you are. These discrete sets are ordered. That lends itself, instead to a logistic regression problem, a ordered probit model. It's a ordered probit, which I've used, but not for a long time, and I haven't seen this explicitly done in any of the common machine learning models. And I'd been racking my head for a while, thinking well, where's the place that it would be used? But here's a good example. Sure, you could just do regression and threshold, but if you want to do the statistically responsible thing, you'll do the ordered probit model. All right, so this is the basic model, and that's a little after 6:30. That's better than I thought, to be honest. Oh, no. Int object is not iterable. Of course it's not iterable. Oh. Right. You want that, you want that. There we go. There we go, much better. N rows is not defined. Of course it's not defined. Okay, that's better. Let's see. Larry's asking. Yeah, he said he started off on the website and it didn't quite work. Oh well. All right, it's maybe next week or in the near future I'll walk through setting up Slimeox and how I do that. Hopefully, the goal is for it to be easy. And if it's giving you pain, then yes, Vim Slime, switch to that. And I guess if you have to use screen, Vim Slime is the one that works with that. I don't think there's a screen version of Slimeox, given the name. I don't even remember. I used to use Vim Slime so much, I used to know this. I should turn on my auto indent. I'm gonna get burned by that later. Flatten that out, and you merge. You do a little this, a little bit of that, and you make the model. That did not actually yell at me. This is amazing. Okay, but I don't have any data right now, right? Therein lies the problem. So what I'm going to do is generate some fictitious data. Just to see if the model does anything, if it will run, to get the shape correct. Because that tends to be the kind of problem that I run into. So this is how I did the fitting before. Okay, so what kind of thing do I need? I need 2 sets of inputs. I don't need this, I think. So let's train fake. No. Fake real is what I want. Occurs to me the enormous irony of calling my fake data named after the real variables, the fake real. Oh man, I was working too hard today, I think. I have not imported numpy yet, have I? I have! Fantastic. Numpy.random. That gives me numbers between 0 and 1, I think. Yeah, and if I say 10, 5, what does that be? That's not what I want. If I just give it a shape, that's what I want. And if I give it a shape that fits in my window, even better. Even better. Okay. So I want n samples to be 100 and 1000, just to have something. Numpy.random, and I want there to be n samples by 4, which 4 is how many real valued inputs I have. I think I have. The recent acceleration, the recent speed, the current distance, the current angle. The current, maybe. Yeah, those are all current. What I'm measuring the real things are. N samples 4, yeah, that's fine. And then fake frame equals numpy.random. It's gonna be a little more complicated. And samples. I want 1 channel, and I want n rows by n columns. I believe that's correct. think that'll do. I think there was something silly about this that I couldn't just... Maybe I couldn't put it in a list. Like I had to call list. I couldn't just use square brackets. It was so strange. Train. Oh, I need some training output too. Duh. Fake real. Fake frame. Fake a cell. Fake A. Fake A. Yep. numpy.random.random. N samples, comma 1. Right? No, I just want n samples. I think that'll be fine. And fake P is the same. Let me undo that. Hang on. There we go. And I believe we can get away with that. And I can say fake A, fake P. For the moment, we do not have any validation data because this is all made up data anyway, so who cares? Okay. Let's see if that works. Does anything. I fully expect this to not be able to climb. I don't want it really to. That wouldn't make any sense. It's got to compile the first time. Kind of irritated that it takes a little while to compile here, but that's the way the business goes. Another question for the audience: why don't I use deep learning libs for models? I am using a deep learning library. I'm using Keras, which sits on top of either Theano or TensorFlow or nothing, your choice. For a lot of these models, it's honestly not that bad to just roll your own, and then you fully understand exactly what you're doing. Once you start getting into convolutions, and here I've got some weird graph structure, that's when it makes sense to use the machine learning model, the machine learning library, excuse me. But it's always important to understand what is your model doing behind the scenes, like mean squared error. What does that actually mean? Yeah, I'm not surprised by these values. Oh, look, the loss is going down. We're winning, guys. We're winning. Look at how fast that was, because there's only 1,000 data points. Brian is telling me that there's only 5 positions for steerage, that I don't get to just do whatever I want, -1 to 1. Okay. So I will sort out how much we can steer then. Alright, well that actually went better than I thought it would as far as having the fake data. Was that the first try on the fake data? I think it was. That's eerie is what that is. That's history. Yeah, and you can compute the loss and the density 1 accuracy. I'm not even sure what this is telling me anymore. Like, what is accuracy when you're got this regression model? Is this how close my my outputs all are? I don't know. You tell me. That's something I would have to look at. Simple model. Yes. Always start with the simplest model you possibly can. If I can build this model in 30 minutes, that is a wonderful, wonderful thing. So now, unfortunately, we're going to get to the hard part, which we're not going to get to tonight. Where the heck do I get data? And how is the data going to ruin all of my assumptions about how to set up this model? Like, I'm going to get images, maybe if I'm lucky, I can get images, a video of cars driving, or like a go-kart going from somewhere. But they're probably not going to be this size. I'm going to have to process all the video to resize it. Am I actually going to be able to get the current acceleration, the current speed, the current distance, the current angle of the steering wheel? Even if now this angle is going to be a categorical variable. It's either going to be at, yeah, hard left, left, straight, hard right, right, yes. So that could throw things off, because now I've got some categorical inputs. So in this case, if there's only like 5 possibilities, I just send each one of those in as an indicator. That's going to be easy, like, or one hot encoding. That's going to be the easiest way to handle that. If it had like 200 positions, for example, if there was a bunch of indicators for different words in a language, this is where this happens. That's when you embed in a linear space. And you've seen that in some previous RNN models I've done. That's where it's very common, doing sequence classification. But yeah, that's how this can get really screwed up. We might have 3 channels of input. Well, what are the inputs and what are the allowable outputs? I think just doing one acceleration and one angle, one phi, is probably going to be the way to go. And then, yes, how do I compute a custom loss function in Keras? Let's briefly, ever so briefly, look at that. Ever so briefly. Loss function, law objectives. Here we go. Available objectives. Oh boy. Callback, Liebler, divergence, Poisson, cosine proximity. This could be trouble. Actual optimize is the mean of the output array across all data points. You must be able to have a custom objective. You must be able to. And if you can't, I'll have to hack one in, or I'll have to stop using Keras and I'll have to go down to Theano or TensorFlow directly, which is not the end of the world, especially after setting all this up. All right, I think that's all we're going to have tonight. Once again, this was setting up a model for an autonomous vehicle based on a few simple inputs, like what is your current situation and what's a webcam snapshot of the road in front of you. And again, this is for the Power Racing series, where people race souped up kids' go-karts, essentially. And it's in association with Fubar Labs in New Jersey. So, all right. Thanks again, everyone, for watching. I'll try to get my old self-driving car simulator working again. We'll see if I can do that. Until then, don't forget you could stay. Oh, gotta work on my tagline, you know. Until then, stay safe in the data mines.